Hey everybody, we are in chapter 4. We're looking at section 4.6 and we're doing regression and median fit lines. Technically we're not going to do median fit lines, we're just going to do regressions and lines of best fit. So let's get started. Our vocabulary looks extensive, but again, not too bad because this one we're not going to do it. It's just something else that our calculator can do. We're not going to use a calculator, so we're going to use a computer and blah, 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 blah. Anyway, let's get into the vocabulary. The best fit line. Now, you guys were doing, kind of approximating linear equations when you had a set of data in a scatter plot. Now we're going to talk about or allow a computer or a calculator can actually give you a more precise line that is called the best fit line. The way of that happening is a process called linear regression, which brings us to this word, and that's the process of finding that line. Correlation coefficient. Sometimes you'll see and we'll see it when we do our data, what we'll see is that given the information that we have, the calculator will use a statistical analysis, a function really, that we're not going to get into, but it's a function that will actually tell you how good your line is. So it can range from, the correlation coefficient could range from -1 to +1. The closer it is to -1, that means it's a strong negative correlation, and the closer it is to +1, then it's a strong positive correlation. However, if it's like close to 0, then there's like no correlation. Kind of remember the concept that we talked about when we had scatter plot and we talked about correlation? That's the kind of concept that's going on here with the correlation coefficient. And then median fit line is a different process that our calculator that we're going to use, or our computer that we're going to use, the program does not seem to do that, so we're going to skip it, and I think we're all good. I don't think it's a big deal. But basically your calculator can use something called the median fit line, which approximates a line using the medians. Fit line, type of line that approximates the, I guess I stopped giving you a definition because I was like, we're not going to do that. All right. Anyhow, so if you would like, you can skip this because I will not test you on it. Let me get a pen here so I can see what I'm doing. Okay, so that's out of here. So the next thing we're going to do is we only have 2 examples, so it shouldn't be that difficult, but you know how it is when you're using technology. You guys are going to have to do me a favor. You're going to have to open up another window to kind of practice what I'm showing you. So I can't actually see all the notes. Your notes aren't going to be as extensive as well. You're going to go to type in Google the word Desmos, and it is a calculator. You're going to launch the calculator and you'll kind of work with me. We'll also have some time to do with this in class, so if it doesn't kind of make sense and you kind of follow along, you're like, give yourself a couple of notes and pointers so in class you'll be able to do it. So here's example 1. We're going to deal with the line of best fit. So the table below shows the amount of money made by movies in the United States. We're going to use a graphing utility, and whenever you see the word graphing utility, it means a graphing calculator or computer or something that graphs equations. To write an equation, FIR is not the word intended here. Let me put 4 in here, for the best fit line for that data. So here's the data right here. We've got years. We're looking at 2000, 2001, 2002, so forth and so on. And we're also looking at billions of dollars, so 7.66, 8.41, etc. What we're going to do is we're now going to open up Desmos, and I'll show you how to do that. Okay, so here we are in Google Chrome. And like I said, I just want you to type in Desmos, and you're going to get a graphing calculator, or click on graphing calculator, and you're going to get this beautiful graphing calculator. Sometimes it doesn't come up like this. I'm going to see if I can do it again and see how you may get it up. Desmos. Desmos, most beautiful. Sometimes you might get this and then it says, okay, I just kind of want you to see what you might get. It says launch calculator, so you can do that. Boom. So here you have this glorious calculator. I'm going to pause this real quick so I can open up the window a little bit. That's a little bit better. That's the most complete view I can do now. I'll try to work on it a little bit again later as we go through this problem. But what we're going to use Desmos for is that we're going to actually put the information that we had in that table that you saw right into the calculator. We're going to let it plot it for us, and we're going to let it give us the line of best fit. Isn't this much easier than doing it for ourselves? All right, so let's see how we do it. I haven't done this a whole lot, so I go to this little plus sign here, and it gives me an opportunity. Here we can put a function in. We know what a function is, just an equation, and we can get this thing to graph it, which is awesome. I don't know what that is. Maybe we can put a note on something, which makes sense. Folder, image. We're going to table because that's what we're looking for. They give us some random points here already, like 1, 2, 3. They already give us some coordinates for x. We can ignore that and totally write over it, and yes, we can continue on. So what I'm going to do is I'm going to put in the information that I had. So I'm going to see, the cool thing is I don't have to like say, oh, I'm going to change this so that I'm using numbers that are easier to graph, because the computer's doing it. So I can put 2000 in there. I can put 2001. I can put what, you know what I mean? You know, like sometimes like we would take a 2000 and make it 0 and take 2001 and make it 1 so we can adjust it. And we can do that here, but now I'm just going to let the computer take care of everything for me. So life is good. So I don't think you really need to see me type this in. So I'm going to pause it. And of course, so for 2000, I will put 7.66. I have the information written down beside me, and I'm going to fill it out. So the next time we talk, you'll see it filled out. Hold on. Okay, as you can see, I already put everything here, and it looks like, you know, whatever, like the information that we had before. Now we got to get this thing to do what it's doing. Some of you might be wondering, well, what about here? What's going on? I can't see the graph. Well, kind of makes sense, right? Because our x-axis is going from 2000 to 2006. Our y-axis is going basically somewhere between like 7 and 10, right? So that's where all of our points are on our y-axis. So let's see how we can see that. What we'll do is we'll go over to, and it's something that you might not be able to see, so let me see if I can move things around a bit. Come on, there it is. If you go over here, you'll see this little wrench, and it's our graph setting. So the graph, I can set the graph to do exactly what I want. Right now, our x-axis goes from -10 to +10. Is that what we want? Not at all. We want it to start at like 2000. Let me start it at 1999, just for kicks and giggles, and then I'm going to go to like 2010. Just to give me like the broad area where this data should be found. So that's the x-axis. Still see no dots? Don't worry. We're going to go look over here at the y-axis. Think about it. What should the y-axis range be? From what to what? Hopefully you remember me saying from 7 to 10. So I think 7 to 10 is pretty good. So I'm going to go from 7 to 10. And remember, this is billions. If I wanted to, I could do you see the dots? Does it make you feel good? It makes me feel good. So I see these gorgeous dots over here. I'm thankful. Don't worry about radians. It's a type of way that we can talk about degrees. We can talk about degrees radians, but we're not dealing with that. That's fine. For conversation's sake, if you go to square grid, that means if it goes out 1, it goes up 1. We don't want a square grid because that's not how our information is labeled. Projector mode, actually, I kind of like it. Makes it a little bit bolder and we can see it better, so I'm going to do that. And I think that's good, obviously, if we're using a projector. With that in mind, let's click back on the graph. Here's our scatter plot. So much better than doing it ourselves. Now, the next thing that we need to do is to figure out how to graph it, get it to graph. And this is a little bit tricky, or at least, I shouldn't say tricky, but it's not intuitive. So let's see how that's going to be done. So I go back over to the left side of my screen, and I click on this doohickey here, and I'm going to look for an equation. So here's it. There's 2 ways that you can do this. I'm going to do one thing, and then I'm going to do another thing. Well, maybe I should, nope, let's just do the line of best fit. Sorry, I was getting excited. So what you're going to do is you are going to use your knowledge of y equals mx plus b. So we're going to put in here y, but notice this y is not just y, it's y sub 1. So I'm going to put in y sub 1. I can click here if I wanted to. Gives me y sub 1. It says 7 elements in your particular, yes, I'm talking about that, is equal to m times, oh, no, sorry. If I do equal, something else happens. I have to use this funky little squiggly line. Don't know why I have to do it. It's in geometry, it's used for similarity. I'm not quite sure why they use it here. Not that one. I'll do it again. It is this one. Nope, just kidding. And joke's on me. Okay, that one. The funky little squiggly line right there. We're going to put it in y equals mx plus b form. So y is approximately, I'm not quite sure why. I don't know why. Anyway, m, and then I'm going to do, and look at all this nice information that's coming out. X sub 1. Look at the line just appear, plus b. And look how pretty that is. Isn't that gorgeous? Let's just take a moment to breathe. It's so beautiful. All right, so just by doing that, we have the line of best fit. How awesome is that? I'll see if I can scroll down a little bit. Oh, look at that. I'm zooming out. So we see it like that. I want to see if I could shift it around. You guys are so much better with technology than I am that you'd be able to see. So here's our line. I'm sure we can play with it so we can get it, but this is the line of best fit given the data, and it's awesome. So why is this so beautiful? This is beautiful because they gave us R, and R is our correlation coefficient. So we see that it's trending positive, but it's kind of low. It's not like really, really close to 1. I mean, it's close to 1, but not really close to 1, given the fact that the range is from -1 to +1. So this means that from the information given, this is the best the computer can do. And it's not like perfectly oriented because, one could kind of interpret different things. But yes, so that's what it is. That's the correlation coefficient. I'm not sure what the parameters refer to. Oh, no, I do know what the parameters refer to. I'm sorry. M is the slope. So the slope would be 0.238. And the y-intercept would be -468. I don't know. I'm just really excited. So we have another one that we need to do. This is it. This is your equation. So if you had to find the equation would be, and I guess I should write it down. Let me see if I can shrink this a little bit so we can write it down on our thingamabob. Okay, I wrote it down here. I couldn't shrink it and like show you both at the same time. But here it is. This is our equation, y. And in this case, y means the billions of dollars or the billions of dollars in terms of income, right? And we could probably use a better variable, but y and this part is x, and x would be the year. So if I take the year and I multiply it by 0.238 and I subtract 468, I would get the approximate amount of billions of dollars that the movie industry in the United States has earned in that particular time. Whoa, it feels nice. I am running short on time and I'm worried about getting into another example, but if I have to do a part 2, you know how we do. So let me pause it here and get into the next example. All right, so here's our next example, and this should go much faster. Example 2, it says use interpolation extrapolation. The table shows the points received by the top 10 paintball teams at a tournament. How many points did the 20th ranked team receive? So now we've got to extrapolate information given this. And to do that, we know we need an equation. So the first thing we do is we observe our data. The next thing that we're going to do is we're simply going to place it inside Desmos and get Desmos to calculate it for us in terms of calculating the line of best fit. So when I do that, let's pause this. So here's our data, and we look at our information, and remember this column is about ranking and this column is the scores. So the first place person got 100, or first place team 100, so forth and so on, and you can see how it is down the line. And you can see there's a approximate negative correlation going on. So we expect a negative equation. We'll do what we did last time. We'll go into, we'll click on the plus sign, go to expression. We're going to put in y, the approximate symbol, which is up like near the number 1 on most keyboards. So I have that. You see what I did wrong? I should have done y sub 1. And I'll show you guys in class what other things you can do that's pretty cool. So mx sub 1 plus b. And then it gives me all the information I need to know. And you check it out. Our slope is a negative 3.32. We've got our correlation coefficient here, and we've got this b value. So now I'm going to use this to get the answer because I'm not done yet. So I'm going to hold this information. I'm going to pause it. Let's go back to our other screen. So now that I've got this handy dandy equation, nothing's stopping me, right? So what I will do is realize that in this problem, X refers to the ranking and Y refers to the score. We need to know how many points did the 20th ranked. So in this case, I'm looking for if X is equal to 20, what does Y equal, right? What is the ranking? So I'm just going to plug it in and do my thing. And by that, I mean plug it right into my equation. So I plug it in and I see that Y 38.59 repeating, so that little bar is up there, and that's kind of ridiculous. So I'm going to write y is approximately 39. So the 20th ranked team probably got approximately 39 points. Thank you guys for working with me today. I know that was a little bit, watching this old lady use technology. But thank you guys for being patient. Play around with Desmos. It's awesome. Your assignment is pages 40 and 41 all. Look forward to talking to you, working with you on it. Can't wait to see you guys tomorrow. Take care.